Today we are going to get additional practice with the partial quotients strategy. Let's start with some story problems. Bridget has 114 shamrock stickers to put in gift bags for her St. Patrick's Day celebration. She wants to put 4 in each bag. How many gift bags can she make? How many stickers will be left over? Oops, that has a typo. We should have a T in there. So let's go ahead and underline our questions here. Spot them with me. How many gift bags can she make? And how many stickers will be left over? What would you set up as your division equation to solve this? So you want the total number of stickers to be your dividend, divided by the equal groups they're being split up into, 4 in each group, your divisor. And that's going to give you the number of gift bags. So now let's use our partial quotient strategy to solve this. So if I put my dividend under the box and my divisor off to the side, I'm going to be asking myself, how many times could 4 go into 114? So I'm going to try to think of some easy multiples of 4. And one that pops into my mind is 4 times 20, right? So if I used 20 bags, how many stickers would that be? 20 groups of 4. 80. So now I've used up 80 of the stickers. Let's see how many stickers are still left over, how many are still in my dividend. 4, 8, 9, 10, 11, so 34 stickers still left. Okay, so this is our new dividend, 34. How many times could 4 go into 34? And without going over, and you're probably thinking, oh, that's 8. 8 times 4 would give us 32. And then we only have 2 left over, which is fewer than our divisor. So that's as far as we could go, right? Because 4 would go into 2 0 times. So we're going to stop there, but first we have to figure out, okay, so what's our final quotient? These were our partial quotients. What do I need to do with them? Add them up to get 28. And then what about this 2 down here? That's our remainder. So 28 R2, or you might see it reported as 28 2/4. That's another way to do it, but we're going to write it like this for now for our purposes, because now we've answered how many gift bags and how many stickers are left over. The leftover stickers are those 2 stickers, and the number of gift bags was that 28 gift bags with 4 in each. That got us as close as possible to 114 stickers. Now we're going to check this with multiplication. If I think 114 divided by 4 equals 28 remainder 2, well then 28 times 4 and then plus 2 more should get me back to my dividend, 114. So let's check that. 8 times 4 is 32. Put down my 2, carry my 3. 4 times 2 is 8, 9, 10, 11. Great, that got me to 112. And remember, I had that remainder 2. So we'll add that on. And now we get to 114. And I like to say, ding, 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 dividend. So we know our answer makes sense. And this check works because division is the inverse operation of multiplication, meaning multiplication undoes division. So once we multiply the quotient times the divisor, then the product will actually be our dividend. Let's keep practicing with another number story. Read it with me. Ava is reading a book that is 162 pages. And another typo, sorry, I fixed this from a previous year where I taught boys, so it should say she wants to read the whole book in 6 days. How many pages will she need to read each day? And let's go ahead and spot our question and underline it. How many pages will she need to read each day? What would your division equation be to solve that? We're going to take the total number of pages, that's our dividend, divide it by the number of days she has, that's our divisor, and that's going to be the number of pages she'll read each day. I'll call it R for to read. Let's show a couple ways, but both of them are going to use partial quotients, because that's the cool thing about partial quotients. There's not just one right way to do it. You just want to think of easy multiples that will be helpful to you. So I might first think, okay, what if I just did 6 times 10? Because 10 is an easy multiple for me. So 6 times 10 is 60. And then I still have 102 left over. Okay, so maybe this time I want to do, should I do 10 again? I could, right? I could use any multiples that are easy to me. So that's getting me closer to 42. Okay, now I can see it. How many times does 6 go into my new dividend? 42. That's 7 times, and that's exactly 42. We have nothing left over. Now what do I do with these partial quotients? You betcha, you add them all up, and that gives us our final answer of 27. So she'll need to read 27 pages per day. That seems like a good goal, good reading goal, at the very least, right? Okay, let's show this another way. I'm going to do the same problem. What if this time I first picked 20? And if I pick 20, then I know 20 times 6 is 120. That's just one of my extended facts. Then I had 42 left over right away here. Okay, same idea. How many times does 6 go into 42? 7. And then I got 42 and subtract to get 0. Now again, I'm just picking these partial quotients 10 and 20 and 7 because they, oh, I forgot to put my final quotient, add up my partial quotients, 27. I'm just picking them because they're easy multiples for me, but again, there's not just one right answer. You could have picked 12, right, and used 6 times 12 as your multiple. You just, the rule of thumb though is you don't want to pick something that's going to make your problem take forever, right? I wouldn't want to do 6 times 3 and then have to do that 9 times to get all the way up to my full final quotient. So pick multiples that are going to get you close to your target of your dividend without going over. Let's see if you could figure out how to set up the check. How would we set up the check for this? If you said that we'll do 27 times 6, you are correct. Let's do that quickly. Put down the 2, carry the 4. 12 plus 4 more is 16. And as I like to say, ding, 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 dividend. We got there. Okay, this next one's a doozy, but if you can tackle this one, then you are a master of partial quotients. So let's do it together. Read this equation with me. 1,925 divided by 7. Whew. I'll give you a hint. Our quotient is going to be in the hundreds. Yep, that's right. Nothing you can't handle. So let's set up partial quotients. And it is nice to think of easy multiples. So I put some examples over here, right? 100 times 7 is 700. I'm going to start with that. Actually, I could even go bigger, right? I could even go 200 times 7 would be 2 times 7 is 14. 2 zeros, 1,400. Hey, that's close to my target without going over. I'm going to start with 200. And then I got 1,400. I subtract. And I still have 525 left over. So let's think of some more easy multiples. 7 times 50 is 350. Oh, maybe that's a good one to do. Or should I go even bigger than that? Let's just stick to 50. So I use 50 and get 350. Subtract. And then borrow. 12 minus 5 is 7. And then 175. Okay, getting closer. I have to think of one more, or a couple more maybe. How many times can 7 go into 175 without going over? Let's see what 7 times 20 would be. Okay, that's 140. Let's try that one. 20, 140, subtract. I told you this problem was a doozy. Okay, yay, only 35 left over. How many times does 7 go into 35? 5 times, and that's exactly 35. So you have none left over. And my final step, what am I going to do with all these partial quotients over here? Add them on up. So 275. Well done. You solved with a quotient in the hundreds. Let's check to make sure we did it correctly. How would you set up this check? If you said that you're going to take 275 and multiply by 7, you are correct. Let's hope we get back to our dividend. 5, carry the 3, 49. 52, carry the 5, looking good. 14, 19, yay, as I like to say, ding, 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 dividend. Okay, so again, once you've mastered this type of partial quotients, you can conquer anything. Good luck as you solve more problems today.